Okay, today's lesson is going to be piecewise functions, what they are and how to graph them. Now this concept is probably one of the more difficult ones that students need to learn, and that's just from experience and seeing how they do on it. So let's take a look at what a piecewise function is. The first thing is that a piecewise function is going to be composed of multiple equations. Now, the whole thing is still a function, and here's an example of one down here. You can see that it says f of x is equal to, and then it's got two equations. So it is a function, meaning we cannot have duplicate x values. It still has to be able to pass the vertical line test. But depending on what value of x we're going to want to put in it, we use a different equation. So let's take a look. So for example, we can see if we want to substitute in a value of x that's less than 1, we're going to have to put it into this equation 1/2 x plus 3/2. However, as soon as we get to the place where we're substituting x values that are equal to or greater than 1, then we're going to switch to putting them into the second equation. So depending on what x value I use, that's what determines which one of these equations I'm going to use. And so when we graph it, it actually has two lines, and you can see that as I go along this way, I'm putting in x values that are negative, and I keep putting negative x values in, and so I'm going to be using this top function 1/2 x plus 3/2. I'm going to be using this function right here. And so that's the line that's graphed. However, as soon as I get to the place right here where x equal to 1, I jump down and have to start putting the numbers into the second function. And that's how piecewise works. Okay? And we'll get to graphing those in a second. Now, one of the first things we're going to do is learn how to evaluate a piecewise. And once again, that depends on the value of x I'm going to use. So what we have here is we have this statement that says evaluate the function of x when a, x is equal to 0, b, x is equal to 2, and c, x is equal to 4. So I need to put in the value of x equal to 0 into this function. And so the thing is which one of the two equations will I put it in? Okay, so we can see that I will use x plus 2 if the x value is less than 2. Well, when I'm putting in x equal to 0, and that's written a function of x evaluated at 0, it would have to go into this equation here, because that's the equation where I'm going to use x values that are less than 2 and 0 is less than 2. So what I'm going to evaluate this at, it's going to go into the x plus 2, so we're going to have the f of x, of course, would be x plus 2, but the value of f will be 0, so it's 0 plus 2, so my function value, or y, will be 2, right? So if I wanted to make an xy table, I put a value of 0 in, and I get a value of 2 out for y. Okay, let's look what happens when I actually put the value of 2 in there. So in this one, x is equal to 2. Well, for the first equation, x plus 2, I only can put in x values that are less than 2. So I can't put it into that equation, but I can put it into the second one because it says use x values that are greater than or equal to 2. So this one will use the value 2x plus 1, and I'm going to put in a value of x equal to 2. Okay, so we can see that in that case, the x value will be equal to 5. Okay, let's go to the third piece, letter C. It says when x equal to 4. So if x is equal to 4, once again, it's going to have to go into this equation because it uses the x values that are greater than 2. So once again, we're going to use the 2x plus 1, and we're going to put a value of 4 in. So the function evaluated at 4 would be equal to 9. Now we're going to learn how to graph a piecewise. And so I put down a set of steps here we're going to do, and I'll talk through them and then show you an example. One thing we want to do is we're going to want to make an XY table for each of the equations. We're not going to use the equations like slope-intercept or anything, because here's the reason why. Let's take a look at this one piece of this function up here. Look at this line right here. It never touches the y-axis. So if I was going to use the form y equals mx plus b, or try to use the equation, I would never be able to use the y-intercept because this line never touches the y-axis. So the way I'm going to do this is I'm actually going to create xy tables to plot. Okay, another thing we need to make sure we're going to do is for each of the tables, I'm going to make a little table for each of these equations, say the x plus 2 and the 2x plus 1. I'm going to make a separate xy table for each of the equations that are in my function. Now we have to be careful that we can only use the x values allowed by this domain part. So say, for example, when I'm plotting x plus 2, I can only use values of x that are less than 2. When I'm plotting the 2x plus 1, I'll have to use values of x that are greater than or equal to 2. So I have to be careful there. Now, I have to kind of go back on what I just said, because we're always going to use the transition point. So for like this above equation here, I am actually going to plug x equal to 2 into both of these equations. I will plug x equal to 2 into this x plus 2 and the 2x plus 1. I definitely want to use this transition point where the x is equal to 2, where it jumps from one equation to the other. But this first equation right here says I can't really use a value of x equal to 2, only ones that are less than 2, but I'm still going to put a value of 2 in there. I'm going to show it on the graph by using an open dot. For this one, where I plug in a value of x equal to 2, because of this equal to sign, when I plot it, I'm going to use a closed dot. So that's how I'm going to get around the fact that I'm plugging 2 into both equations. Okay, and now then I'm going to plot those points, and remember that I cannot have the x values overlap on the graph because it still has to pass the vertical line test. So let's go ahead and try an example. So what I have is I have this piecewise where the where we use the equation 2x plus 3 if my values of x are less than or equal to 1, and use a negative x plus 4 if my value of x is greater than 1. So here's how I will do this. I'm going to set up an xy table for the 2x plus 3. And remember, we're going to use values of x that are less than or equal to 1. So I'm definitely going to use the transition point of 1. When I plug 1 into this equation, I get 2 times 1 is 2, plus 3, I get a 5. For my second point, because it's going to be a line, I need to pick another value of x, but the x value needs to be less than or equal to 1. So I need to pick some other point. How about if we pick a negative 1, because a negative 1 is certainly less than or equal to 1. So what I have is I would have 2 times a negative 1 plus 3. That'd be a negative 2 plus 3. I would get 1 out. So for this particular part, the 2x plus 3 up here, I'm going to have a closed dot because look, this value of x, this x can be equal to 1. I plugged the 1 in here. This will be a closed dot. So at 1, 5, I'll put a closed dot. Then the other point is a negative 1, 1. So I'll go a negative 1, 1. And this is for values of x that are less than or equal to 1. So the values of x that are less than or equal to 1 go this direction. So there's a 1/2 of my graph. Now let's do the next part. Negative x plus 4. And there's my xy chart. And I'm going to need to pick values of x that are greater than 1. However, I am going to use the transition point of 1. If I put 1 into that equation, I get a negative 1 plus 4. Negative 1 plus 4 is going to be 3. And because the value cannot actually equal the 1, notice that that has a greater than sign, I will show that by an open dot. All right, let's pick another value for my table where x is greater than 1. Let's pick 3. So if I put a 3 into the equation, I get a negative 3 plus 4. That would be 1. So for my second part, I'm going to graph that. I'm going to have 1, 3 with an open dot. 1, 1, 2, 3, there's an open dot. And I have in the other point 3, 1. 1, 2, 3, up 1. So this part of the graph then is going to go this way. Notice that it would still pass the vertical line test. There are no points where I would cross in two x values. Right here, there's a closed dot, but an open dot, so that x value really doesn't exist there in that open dot, so once again, that passes the function test. Okay, let's do a few more. So this one, I have two values, or two equations. I have one where I'm going to use y is equal to 1/2 x plus 3/2. And I will use values of x that are less than 1, but always use the transition point of 1. So x, y, let's do this table. If I plug in a value of 1 for x, I'm going to get 1/2 times 1 plus 3/2. So that would be 1/2 plus 3/2 is 4/2. That would be 2. And that's going to be an open dot because there's no equal to sign. Now I need to pick another value for x that is less than 1. So maybe let's try a negative 1. If I plug in a negative 1, I get 1/2 times a negative 1 plus 3/2. That would be a negative 1/2 plus 3/2, which would be 2/2, which is 1. So I have my points to plot. I have the point 1 up 2, and that would be an open dot. I have the point negative 1, 1, negative 1, 1. And this shows values of x that are less than 1, so that's going to go this direction. Let's plot the other part. Y is equal to a negative x plus 3, my xy table. Pick the transition point of x equal to 1. If I put 1 into this equation, I get a negative 1 plus 3. That's going to be equal to 2. Now then, let's pick another value, a point that is greater than 1. I can pick 3. So this would be a negative 3 plus 3 when I plug that in, which would be equal to 0. So I have those 2 points. Now this one will be a closed dot because it has an equal to here. And so let's plot it. So I got 1, 2. And when I plot it, that's going to fall right on top of my open dot. And that's okay, no big deal. And the next one is 3, 0. So that part is going like that. One more. Graph f of x is equal to 1/2 x plus 1 when x is less than 6. It's equal to x when x is greater than or equal to 6. So I'm going to make my two xy charts. This one is going to be 1/2 x plus 1. And that's going to be for when x is less than 6. So here my transition point is 6. So let's put a 6 into that equation. What I would get is 1/2 times 6 plus 1. 3 plus 1, so I get 4. Notice that for that equation, there is no equal to sign, so this is going to be an open dot. I have to use a value of x that's less than 6, let's pick 0. If I put a 0 in here, 1/2 times 0 is 0 plus 1. You get 1. So here's the points for that part of the line. I've got 6. 1, 2, 3, 4. And that is an open dot. And then I have 0, 1. And the values are less than 6 that go into that equation. So there's that part. Let's graph the other one. Y is equal to x. And for this, the x values have to be greater than or equal to 6. Let's make our xy chart. Let's use 6. So if I put a 6 in for x, I get a 6 for y. Because there's an equal to in that equation, it's a closed dot. I put an 8 in for x, I get an 8 for y. So 6, 6, 6, 1, 2, 3, 4, 5, 6, and 8, 8. And those are for the values that are greater than or equal to 6, so that part of the line would go this way. Once again, you can see there is no overlap anywhere. So if I want to check the vertical line test, you can see no matter where I go, I'm only going to pass 1 point. If I go right at the value of 6, it hits a closed dot, then an open dot, so I'm still good for the vertical line test. That's piecewise functions.